We're going to calculate how much heat is gained or lost in these following changes. So these are all phase changes, or at least A, B, and D are. We're given this reference chart from our textbook, so we'll use that to solve these problems. Let's go with A. All right, this is freezing, water freezing, and so freezing is when liquid goes to solid, but we are given the heat of fusion, which is melting. So heat of fusion is from solid to liquid. It's how much energy is required to melt 1 mole of these substances. So if you want to flip that, you just flip the sign. So instead of 6.01, it would be negative 6.01 because going from liquid to a solid is exothermic. Those particles need to lose that kinetic energy to lower their temperature. Losing energy is exothermic. So we can use the same value because energy is conserved. So we'll just use the heat of fusion value and just stick a negative sign there. All right, so let's start. Let's do A here in blue. Start with the number given, 3.50 moles. All right, we need to turn that moles into a unit of heat. So kilojoules will do because we're given the molar heat of fusion. So 1 mole, let's go back here, is in this case going to release negative 6.01 kilojoules of energy. So let's punch that in our calculators. 3.5 times negative 6.01. Make sure I did that right. 3.5 times negative 6.01. Okay, and we got 3 sig figs there, 3 there, so answer's gonna have 3. So it's gonna be negative 21.0 kilojoules is the amount of heat released when water freezes. It's not sometime soon it's like, wait, what do you mean water freezes? It's cold. Yeah, but it's releasing heat to get there. The only reason it's cold is probably because it's in a cold place to begin with. But freezing is exothermic. Let's do B. This time we have steam condensing, so there's gas to liquid. We're going to need the molar heat of vaporization. Right, so go from gas to liquid is again, let me do this. So the molar heat of vaporization is the amount of heat, energy required to turn 1 mole of liquid to a gas. That's called vaporization. All right, and for water, it takes 40.7 kilojoules per mole. So it requires a lot of energy to boil water. All right, liquid to gas. Now, the question is not asking about vaporization. Condensation is the opposite process. So again, if we want to flip this process, we can just flip the sign there on the heat of vaporization. All right, 40.7, negative 40.7, sorry. Let's start with the number given, 0.44 moles. All right, and let's turn that moles into kilojoules. And it's negative this time because condensation is exothermic, 40.7. 0.44 times negative, 0.44 times, there's so many 4's here, negative 40.7. All right, we got 2 sig figs here, and then our answer has to have 2 significant figures. So 18, negative 18 kilojoules is how much energy is released when 0.44 moles of steam condenses. All right, let's. By the way, part C, if you're just curious, that's the enthalpy of solution. It's just how much heat change is involved in the dissolution of 1 mole. I think sodium hydroxide is like 44.5 kilojoules per mole. So just multiply that number by 44.5 and negative 44.5. It's slightly exothermic. So you will get your answer by doing that. But let's go on to D. water vaporizes. So, oh no, I'm sorry, this is not water. That's ethanol. Ethanol vaporizes. All right, so we're given ethanol up here. Here it is. So the molar heat of vaporization for ethanol is 38.6, and we don't have to flip the sign because vaporization is, again, liquid to gas. And that's exactly what it's describing here, vaporizes. So we're just going to use 38.6 kilojoules per mole. All right, let's start with the number given, 0.15 moles of ethanol, and let's get rid of moles, turn that into kilojoules, and that was 38.6. Let me just check. Yep, kilojoules per mole, moles cancel out. Punch those numbers in. 0.15 times 38.6. And we need two significant figures here because there's only two there. 5.8 kilojoules is how much heat is going to be absorbed. Forgot to cancel these out earlier. All right, and that's this is an endothermic process because liquid to gas, it needs those particles in the liquid have to absorb energy, absorb kinetic energy to have enough to vaporize. There it is.